Okay, so hopefully you made out on 1.1 already. Today what we're going to look at is arithmetic series. So the first thing that we did was an arithmetic sequence. And we started by going 2, 4, 6, 8, 10, and so on, in which our common difference was 2. So what's the difference between an arithmetic sequence and arithmetic series? An arithmetic sequence just deals with the actual pattern itself. An arithmetic series deals with the sum of all of the terms combined. So for example, that. All right? So if I was to look at this and I wanted to find the sum of this sequence, all right, this series, I go 2 plus 4 plus 6 plus 8, in which the common difference, I can find the pattern by adding 2 to each one. So I got 6, 12, 8 is 20. So what I do to find any of the terms is I take t to the 1, and then I'm going to add it to my next term. Well, how do I get my next term? I take the previous term, and I add d to it. So in this case, this is term 2. Term 3 then is term 4 then would be, and then you keep going from that point on. All right? Because each time you're just adding and adding the difference. And so depending on how many terms you have, you can come up with the sum of the terms in the sequence. Now, what if, for example, I wanted the 48th term of this sequence? I wanted to find the sum of the first 48 terms of this series. All right? To do that, I use another equation. Again, this will be an equation that will be given to you. So it's found by taking n over 2 times, now there's two ways in which we can do this. We can go twice the first term, all right, times d, or we can go n over 2, t to the 1 plus, if we know what the last term is, we can do it that way as well. All right, where t to the n is the nth term, if we know it. Otherwise, we have to use this as our way in which we find our sum of an arithmetic series. Okay, so I'm going to make that smaller so that we have those two equations with us. You'll be given both those equations on the test. So here it is. A toy car, on page 15, a toy car is rolling down an inclined track, picking up speed as it goes. The car travels 4 centimeters in the first second, 8 centimeters in the second, 12 centimeters in the third second, and so on. How far does the car travel in the 50th second? So we're asking what the series is then. So t to the 1 is 4 centimeters. T to the 2 is 8 centimeters. T to the 3 is 12 centimeters. And I want to know what t to the 50th is, I believe. Yeah. Okay? So to get the 50th, we use our equation. T to the 1, which is 4, plus n minus 1, which is 49, times my common difference. Well, I haven't found my common difference yet. So to find my common difference, take T3 minus T2, and we get 4. All right? So what's that? That'll be 200, I believe, right on the nose. Car travels 200 centimeters in the 50th second. Okay? Then it says, determine the total distance traveled by the car in 50 seconds. Well, I know what this term is. So I can find the sum by taking my first term. Oops, a little too quick on that. So I want the sum of the first 50. So I'll put that there. Sum of first 50 is 50 divided by 2 times 4 plus 200. Like that. Okay? Because I know the t to the n, I can calculate it that way. So that's one way to do it. So I get 25 times 204, which is 51,000. Oh, not quite. 25 times 204. 5,100 actually. Centimeters total in that 50 seconds. And you could have used the other equation, n over 2, t to the 1, which is 4, plus, or 2 times t to the 1, so this guy, 2 times 4, plus 49 times my d, which is also 4, and it would still give you the same thing. Both methods work. Both are equally effective. Okay? Does get a little more difficult than this. Looking at page 16. Determine the terms of an arithmetic series. The sum of the first 6 terms of an arithmetic series is 297. So S6 is equal to 297. The sum of the first 8 terms is 500. S to the 8 is equal to 500. Determine the first 10 terms of this series. All right, so we've got to find the first 10 terms of the actual series. So we're not looking for, we got to somehow use this to help us. All right. So what am I missing from this equation? Well, I'm either missing my d value. I don't know what my d is, but I definitely don't know what my t1 is. Okay. So let's use the equations that were given to us to solve for it. All right. So the first equation would be this. So I'm going to take the 500 is equal to. So that's my 8th term over 2. My t to the 1, which I don't know what it is, right? And then I'm going to add that to my 500, which is my 8th term. No, that doesn't work. Why doesn't that work? Because this isn't t to the n. This is s to the n. So I can't use it doing it that way. So let's backtrack and try it again. So now, what that means is I can't use this equation here because I don't know the nth term. And I don't know the t to the 1. So I'm going to have to use this equation up here in order to do it. Okay? So let's go 500 again is equal to 8 over 2 t to the 1, 2t to the 1 plus n minus 1, so that's 7d. Okay? So I'm going to simplify this now. All right? I'm going to simplify this. So that's 4 right here. I'm going to divide 500 by 4. So 500 divided by 4 should be 150, I think. No, 125. So I have 125 is equal to 2t to the 1 plus 7d. So again, this goes back to our applied math course that we've just finished. All right? Yeah, I know, you're excited about that. What we're going to do now is we're going to take this one and do the exact same thing. So I've got s to the 6, which is 297, is equal to 6 over 2, 2t to the 1, plus 5d. So 297 divided by 3. Should know that. That's 199 probably. Is 99 equals 2t to the 1 plus 5d. So now I'm going to do the same steps that I did in the last section with the series, or with the sequences, sorry. 125, 2t to the 1 plus 70 and 99 equals 2t to the 1 plus 5d. So what did we do in the last one? Because I'm dealing with a common difference, I'm going to subtract them. So 125 subtract 99. 26 is equal to 2t to the 1 minus 2t to the 1 is 0. 70 minus 5d is 2d. D is equal to 13. Okay? So now I have D equals 13. I still have to find, or I still have to calculate then, what is my T1. So let's plug that back into this equation here. So I'm going to go 99 equals 2 times t to the 1 plus 5 times 13. So 2t to the 1 is equal to 99 minus 65, 34. T to the 1 is equal to 17. So then it said from there, calculate the first 10 terms. So 17 plus 13, add another 13, add another 13, and so on. So that's one of the two methods in which we could do to solve for this particular equation. All right? This is the hard part. This is the length of it. It's not terribly difficult, but this goes back to applied and that subtracting and adding and subtracting to find variables with two unknowns in them. Okay? All right. That's the only example I'm going to show you for right now. So you have, again, questions on 18 to 21. Again, there's a lot of questions, so get through as many as you can, but don't feel that you have to do all of them. All right? And